Assalamualaikum YouTube viewers. The topic of today's video is symmetry in the molecule of benzene. So as you can see here that there is a molecule of benzene on your screen. Okay. And you know that in the molecule of benzene there are 6 carbon atoms. So here it is a carbon atom, again carbon atom, carbon atom, carbon atom, carbon atom, and again a carbon atom. So as you can see here that we have 6 carbon atom here, and then we have a hydrogen atom here. The white represents the hydrogen atom. So there are no double bonds being shown in this diagram. Why? Because double bond does not matter in case of symmetry. So in symmetry, what we have to do, we have to just take the shape of the molecule of benzene. So here I have just shown you the shape of the molecule of benzene here, and each there are 6 carbon atoms. There are total 6 carbon atoms, and there are total 6 hydrogen atoms here. Okay, so now the first of all there exists an identity in this molecule. Okay, as you know that identity means 360-degree rotation. Means if I give this molecule a 360-degree rotation, what will happen that this molecule will come back to its original shape. Moving on towards the axis of rotation, as you can see here that benzene has C6 axis of rotation. As you know that I have 60-degree angle between each of the carbon atoms. Means that the angle between this carbon atom and this carbon atom is 60-degree, and again this carbon atom and this carbon atom, the angle between them is 60-degree. There is a 60-degree angle. This angle is of 60-degree, and again this angle is again a 60-degree, and this angle here is again 60-degree, this angle here is again 60-degree, and this angle here is again 60-degree. So as you know that there is an angle of 60-degree that exists between the carbon atoms, between the adjacent carbon atoms. So what happens? How can I find the principal axis of rotation? It means that if I give this molecule a C6 rotation, then what will happen? That then this molecule will have the initial configuration. C6 rotation. What does it mean by C6 rotation? Well, 360 divided by 60-degree will give me an answer equal to 6. Okay, if I divide 360-degree by 6-degree, my answer comes out to be equal to 6. So 6 is the value of n. It means that I have to give C6 rotation. So here's the C6 rotation. C6 rotation means that every carbon atom will replace the next carbon atom. Every carbon atom will replace the next carbon atom. So let me just show this. So here, as you can see, that each carbon atom has replaced the next carbon atom. So that's the C6 rotation that exists in the molecule of benzene. So moving on, what more rotations are present in the molecule of benzene? So C3 means that I have to give a rotation of 120 degrees. Okay, how did I find that I have to give a rotation of 120 degrees? 360 divided by 3. Since I am giving a C3, so n value is 3. So 360 divided by 3 will give me an answer equal to 120 degrees. So that means that I have to give a 120-degree rotation to the molecule of the benzene. So here, as you can see here, that if I give the 120-degree rotation to this molecule, what happens? This carbon atom will go all the way through this carbon atom, and this carbon atom will go all the way through this carbon atom. So every carbon atom will get a 120 degrees of rotation. So let me just explain this by the help of the animation. So here, so as you have seen that each carbon atom has replaced the next to next carbon atom. Keep your focus on this carbon atom. This carbon atom will go all the way to this carbon atom. So here, okay, so that was the rotation, that was the C3 rotation that exists in the molecule of benzene. So there is also C2 rotation that does exist in the molecule of benzene. So C2 rotation means that 360 divided by 2, since n value is 2, so what I have to do, 360 divided by 2 equal to 180 degree, means I have to give a rotation of 180 degrees to this molecule to get the initial configuration. So 180-degree rotation means that this carbon atom here will go all the way to replace this carbon atom, and this carbon atom will go all the way to replace this carbon atom. So let me just explain this with the help of animation. So here, that was the animation showing the C2 degrees of rotation. So if C2 exists just like this, there is an other C2 that does exist here. Okay, that C2 is just like this, means that if I give the rotation along this axis, these carbon atom will replace these carbon atom, and these carbon atom will replace these carbon atoms. So let me just explain with the help of animation. So here, as you can see here that I have given the animation, and as you can see these two carbon atom has gone all the way to these carbon atoms, and these carbon atom has gone all the way to these carbon atom to give me the initial configuration again. So that was a C2 configuration that exists in the molecule of benzene. Moving on, towards more rotations. So these are some other C2 rotation that does exist. For example, let me just explain it with one by one. So here, as you can see, C2 in the benzene also exists just like this. C2 in the benzene also exists just like this, that if I give 180-degree rotation along this, what will happen? These three carbon atoms will replace these three carbon atoms, okay? And then again I have another C2 just like this, okay? And I have another C2 just like this, and these three carbon atoms will replace these three carbon atoms. Then again I have another C2 that exists along this axis. These three carbon atoms will replace these three carbon atoms. So what I'm going to discuss is that these are the three C2 axes, and overall there are many other C2 axes. One is this. First of all, let me just, okay, there was this C2 axis, and again along the carbon atoms there is an other C2 axis, and again along the carbon atoms there is an other C2 axis. So what do I have here is three C2s along the carbon atoms and three C2s between the bonds, okay? And between the bonds there's number one C2, and then between the bond there is again a C2, and then between the bonds there is an other C2. So how many C2s do we have? We have 1, 2, 3, 4, 5, 6 C2s, and the seventh C2 is along the perpendicular to all of these. So there are 7 C2s in the molecule of benzene. Okay. So how many C3s are there? There is only one C3 and there is only one C6. Okay. So what is the principal axis of rotation in that case? In that case, the principal axis of rotation should be C6, because as you know, the principal axis of rotation is the one that has the maximum value of n. So as you know that n has a maximum value here that is equal to 6. So I can say that C6 is the principal axis of rotation. So these were all about the symmetry. These were all about the axis of rotation in the benzene. So moving on towards the inversion. As you know that inversion does exist in the molecule of benzene. So inversion means that each molecule, each atom will replace the next atom. Okay, this atom will go all the way through to this atom. Similarly, this atom will go to this atom, and this atom will go towards this atom, and the opposite atoms will go towards the opposite carbons. So let me just explain it with the help of the animation. So as you can see here, every atom has replaced its front atoms. So this atom will go here, and this atom will come back here, and this atom will go here, and this atom will go here, this atom will go here, and this atom will go here. Every atom has replaced the other atom. This is the inversion. So after inversion, my molecule has same initial configuration. That means that inversion exists in the molecule of benzene. So there was inversion. What more is present in the molecule of benzene? We do have an S3 axis of rotation, and S3 is the improper axis. So how does S3 exist? As you know that we have a C3 axis of rotation. Okay, we have a C3 axis of rotation. As you know, we have a C3 axis of rotation. So C3 axis of rotation means that each carbon atom will replace this carbon atom, this carbon atom will replace this carbon atom, this carbon atom will replace this carbon atom. Okay, it means each carbon atom has to replace the next to next carbon atom, not the next one, not the adjacent one, but the next to next carbon atom. Each carbon atom has to replace the next to next carbon atom. Okay, so that's C3 rotation that I have just shown you before. And if I pass a perpendicular plane to the C3 axis of rotation, what will happen? I will get an initial configuration. So that's what we have is S3 axis of rotation. That's here. We have a C3 axis of rotation, and then this perpendicular plane cuts the carbon atoms, cuts the benzene molecule into half, leaving us with the initial configuration. So that's an S3 configuration that we have here on the screen. So moving on, what more type of rotation, what more type of axis of rotation can we have? We have an S6 axis of rotation. So S6 axis of rotation means that what I have to do is to just give a C6 rotation. C6 rotation means that this carbon atom will replace the next one, and this carbon atom will replace the next one, and this carbon atom will replace the next one. Similarly, this is the C6 axis of rotation. And then what I have to do? I have to just pass a parallel plane. I have to pass a perpendicular plane, not parallel. I have to pass a perpendicular plane to this C6 axis of rotation, and that will leave me with an S6 improper axis of rotation. Okay, so that's the S6 improper axis of rotation that do exist in the molecule of benzene. But someone may ask, is there an S2 axis of rotation? So S2 axis of rotation is similar to that of inversion, so we do not consider the S2 axis of rotation. Okay, so sigma h. What is sigma h, and what is sigma d, and what is sigma v? Okay, sigma h is actually the plane that is perpendicular to the principal axis of rotation. So what was our principal axis of rotation? The principal axis of rotation was C6. As you know that in case of C6 we have the maximum value of n, so C6 has the is the principal axis of rotation. So the plane that is perpendicular to this C6 will be the sigma h. So here as you can see here that this plane is perpendicular to this C6, that means that this one is a sigma h. And then sigma v's. What are sigma v's? Sigma v's are all the planes that are parallel to the C6 axis of rotation. Means the sigma v are all those planes that are parallel to the principal axis of rotation. And in this case, how many planes do we have that are parallel to the principal axis of rotation? We have 3 sigma v's. Okay, one sigma v is just like this. First of all, let me remove the sigma h. So here I have removed sigma h. So now what I have here is a sigma v. As you can see here that this sigma v is parallel to the C6 axis of rotation. And then again we have another sigma v along the other 2 carbons. And then again we have another sigma v that is from the other 2 carbons. So these are the 3 sigma v's that we have in the benzene molecule. So now these are the sigma v's that we have in the benzene molecule, but we also have sigma d's. What are sigma d's? Sigma d's are actually those plane of reflection that are present between two C2 axes. Okay, sigma d are two planes of reflections that are present between two C2s. Okay, first of all, let me just remove the C6. So here I have the C6 removed. So here as you can see that I have a sigma d. Okay, and as you can see that this sigma d is present between two C2 axes. One C2 axis is this, the other C2 axis is this. So this sigma v is present between two C2 axes. So this is the sigma d. Okay, the sigma v that is present between the two C2 axes is known as the sigma d. Okay, sigma d is actually a type of sigma v that is present between the two C2 axes. Okay, so now this is one sigma d, and then we have another sigma d, and then again we have another sigma d. So what do we have? We have 3 sigma d's, and then we have 3 sigma v's here. Okay, so let me just explain it further that as you can see here that this one here is a C2, this again is a C2. So first sigma d is going to be present between these two C2's axes. Okay, so again the next sigma d will be present between the next C2 axis. So as you can see here that this sigma d is present between this and this C2 axis, and the last sigma d is present again between this C2 axis and this C2 axis. Okay, so sigma d's are present between the two C2 axes. So that was all of the symmetry elements that are present in the molecule of benzene. So that counts up overall to the order of 24, and the benzene has a point group of D6H. Okay. Okay, so that was all for today's video. If you have any question, you can ask me in the comments or you can email me. Thank you and Allah Hafiz.